Hello guys, in this video we'll build a SQL agent which helps us talk to a database using natural language in Rust. Basically, writing a SQL query could be very tough when you are dealing with multiple tables or even when you are dealing with a simple yet complex column table. So in this video, we'll build that SQL agent that helps us talk to our database with natural language, and we'll be using open source LLMs. As always in my videos, we'll be using Olama. So we can use different models like Llama 3.2. We can use specific models which are designed for SQL generation, which we'll see in a minute. And we'll be using PostgreSQL database. We can spin up as a container, or we can use pgadmin if you have it on your machine. Another purpose of this video is to build small yet efficient and productive AI agents and LLM ops, and then we can build on top of that knowledge for the future videos where we'll cover more complex use cases of AI agents which can help us to book our flights, hotels, or even can perform customer support or do more complex and tricky tasks like selecting the next stock which we should invest in. So we'll cover all of that, and additionally in this video we'll learn how can we design such chains, such LLM or lang chains by our own. We'll not be using any crates which are available there. Instead we'll design by our own to see how can we process tasks in steps, like for example generating your prompt and then feeding it to your model to generate query from your prompt and db info, and then running it against your database. So it's like series of steps which we can then follow for different purpose, like PDF extraction or such similar tasks. So without further ado, let's dive into it and let's begin. And as we start, there's a link to my Discord in description. Make sure to join it. First of all, let's look at our DB setup. Now, Postgres running on your machine or pgadmin is not a must. We can easily spin up Postgres with Docker Compose and use Diesel to create the table, but we have been doing it in our previous videos. But in this video, just for a change, I thought let's use a more traditional SQL setup, which is a server, and then you can also have pgadmin UI where you can query and perform tasks on your DB, and then you can connect from your code as well. So we'll design our agent in such a way that it could generate a query for n numbers of table depending on what user is asking. But for this specific video, for the demo, we'll just use the users table with some dummy data, as you guys can see here. And the queries could be get me Elias Johnson's email or Bob Smith's password, or get me the address of Bob Smith, or how many mails are in this table. So we'll just perform such queries and see how our LLMs can help us generate, and against that we'll just run in our DB. Let's quickly add our dependencies. So cargo add Tokyo and features as full, and then we need Olama RS. Cargo add Olama RS, and then we need anyhow for error handling, and then we need async trait, and finally we need SQLX. So cargo add SQLX and features as Postgres, runtime async std, and runtime Tokyo. Okay, so once we have all, we'll just reload. So there we go, we have all of the dependencies that we need. Now let's move to chain RS. Here we'll add our chain trait and we'll try to make it dynamic. So in future, if we extend it to, let's say, not just text to SQL, but text to PDF extraction or text to anything, we can just use the functions and build another chain as well. So pop trait chain, and this is an async trait. So async fn initialize, and here we'll return result box, again something which we have covered in previous videos. If you haven't checked out, make sure to check out when and how can we use chain, what is sync plus send. The video should be popping somewhere on right top. And anyhow error. So this is our initialize, where we want self to be sized. So what we are doing here is anyone that implements chain can extend this method, which is initialize, and then return your own chain. So this could be dynamic, let's say text to SQL chain, text to PDF extraction, or text to maybe CSV extraction, or whatever you want to build. Then just extend this chain. And we have initialize. Guess what else we would have here is run. So we'll just add async fn run, input string, and output as again result of string or error. As straightforward as this, we have our chain ready to be used. Now we can just extend this on our text to SQL today, but in future we'll try to extend it on other as well. And if you're someone new to Rust and not yet familiar with box, dynamics, and self-sized, I've covered in previous videos, should be popping somewhere on right top. Make sure to watch it. Now let's go to our text to SQL chain, and here let's build our chain. By the way, before we start coding our text to SQL chain, you guys should be familiar with how to run Ollama models locally if you want to use the same models as me. Then make sure you are familiar with Ollama CLI and how can we run these models locally. I've covered in a previous video, should be popping somewhere on right top or in the description. You can check out that video, so make sure to click and check. So let's start building with the trait that we just add, create chain, and we'll also need SQLX, Postgres, and PG pool. So pub struct text to SQL chain client Ollama and db as PG pool. Then we'll impel our chain for text to SQL chain, and this is an async trait. Now let's add our definitions for initialize and also run. So another dependency that we need is .env. So cargo add .env, and once we have .env, there you go, we have .env now in our project, which we can use to access our secrets, which we just can save in our .env. As you can see, I have already stored my database URL in env, and now let's start using it. So .env .ok, and let db URL environment var, and here we'll just pass database URL. That's what we want to read. Expect database URL must be set, and let pool is equals to PG pool, and connect. Let's pass the database URL, await, and once we have our pool, we can just do OK, box new, and text to SQL chain client as Ollama default, since we have Ollama up and running on our local and we are serving the model on local, and dbs pool. So that's for our initialize. Pretty straightforward, nothing fancy. Now let's add run. Now even before we add our run, which is kind of series of steps, let's add the methods that we'll need in our chain. So impel text to SQL chain, and right here will construct our db info. So let's add a method for that. Now db info we need because when we are sending out the prompt to our model, we want model to have more context of how our tables and the columns looks like. So async fn get db info. Now again, there could be tons of ways of how we want to build this, but I would just want to query db and get this information. So we can just do is tables query, and we can do select table name from information schema dot tables, where table schema is equals to public. And once we get all the rows, so SQL X query and tables query, fetch all and pass the pool and await. So once we get our information, tables info vector new, and I want to pass it just like how a schema would look like, which we'll see in a minute how we want to pass it. So for row and rows, let table name as string row dot get table name, and let columns query. Then we want to extract the columns for that table. So select column name from information schema dot columns, where table name is the table name that we pass, and that would be the table name. So we get our query, we retrieve our columns, SQL X query and columns query, fetch all and await, let columns vector of string and column rows dot iter dot map call row and call row dot get column name. So let's do column name collect. This will give column names. So here let's first get the result. Self dot get db info dot await dot unwrap or default, or just let's use unwrap since we just want to quickly test it. Okay, result. And once we have it, let's go to our main, and right here we'll just quickly add async mains, and this is Tokyo main. So let processor text to SQL chain initialize await and unwrap. Let mutable input, let's take the user input new, and we just print saying how can I help you, and let's flash this std out flash, and then we take the user input. So simply do just std in read line and mutable input to take the input, expect failed to read line, and let output processor dot run with whatever the input is, await, unwrap, and then we just print the result. Output. So pretty straightforward. The main will always remain like this. Right now we are just checking how we are formatting our DB info, but even for our future output it remains the same. Okay, fair enough. Now let's go ahead and try to run this. And right here we'll just do cargo run quite. So let's provide our input, get xyz for now. Okay, so there you go, we get our response, which is currently just the schema that we are getting from the DB. So this is something that we want to reject, so we can drop it, or let's keep it as it is. But then is, if you can see, we get our users as a table, and then the user ID, age, email, password hash, phone, country, gender, all the columns that we have in our DB. So looks good. Let's say if we have 10 tables, then it will just bring all them comma separated here. So yeah, I think it looks good, and something that is a good checkpoint for our code. Since this part of the code, the main will remain as it is, so let's move to our text to SQL chain. So we have our get DB info. Now we want to construct the prompt, so let's do that. The construction of prompt is also pretty straightforward and depends on which model again you want to use. So self input string result and string error, db info, self dot get db info, and await, expect, failed to get db info. Okay, format, and provided this schema, which is our schema, generate SQL, generate executable SQL query that answers the question. And here we can add our user's question, and also we can just say only return SQL query. So db info and user input. Actually this won't be here. Okay, so we have our construct prompt as well, and now after this we need an executor or a function that could, help us execute whatever the query that GPT gave to us. So async fn query, and query or generated query, and result of string error, let rows SQLX query, and generated query dot fetch all, and self db await, let mutable result string new So for row in rows, let mutable row string new, and for index comma column and row dot columns, iter enumerate, let column name, so whatever the column that we get, and let's scroll all the way top, and here we start using use SQLX column row, so we can easily access the methods. And right here, so here we'll just do let value option of string row dot try get index and unwrap or none, and row string dot push str and format. So right here we'll just do column name and value, and just to make it look more clean, we can just do if row string dot ends with any trailing commas, row string dot truncate row string dot comma or space dot length -2, and then finally we have result string dot push str and format. So this is to push the result, and let's do row string. So finally we return OK of result string. This will give us our result. So everything is ready. Now we just need to call our LLM. We need to just get our prompt and run. Now the final step is to put our chain together and start running it. So let's first of all add the prompt. Self.construct prompt, passing the input, and wait. Once we have our prompt, we can then just do request, which is the generation request, and new. So here we can provide our model name and the prompt we already provided. Now let's provide the model name. So string from we'll just use llama 3.2 on my machine, and let SQL is equals to self.client, and generate, pass the request, and await, unwrap. Once we have it, we'll just go ahead and let's even use dbg to show the SQL that's generated, or we can just do more fine grained, something like SQL generated, and here we can print our SQL, and then we can just do let data is self.query and pass the SQL that we have. Actually we just need SQL response, so let's get only the response. So query as response or SQL, await, unwrap, and finally we just return OK of data. That's pretty much everything that we need, and we are using the input. So everything is pretty much ready here. Let's move to our main. We don't need to make any change here, so let's start testing our application. Now let's run our application, and we are asked for the input. So let's say we want the address of Bob Smith, so get Bob Smith address. Let's see the query. Okay, so there you go, the generated query is correct. Select address from users where name is Bob Smith, and we are able to get Bob Smith's address. So in similar way we can perform many other queries. Sometimes it will be very accurate since we are using Llama 3.2 on local, very small model. Try exploring with other models as well if you are not able to find the accuracy that you want, like bigger models. But yeah, definitely it works. So that's it for this video, guys. I hope you guys understand and learn something new. We can also plug this into a UI, which we'll do in the future videos, and basically help our customers or our users just query from the UI. I'll catch you guys in the next video. Thank you.